Again, good evening, everyone, and welcome to the Unlocking PSP study group meeting. Today, we will discuss domain 2, task 2, and this will be the section 2 because this is a huge topic. And today, we will try to cover in electronic security system, access control, intrusion detection, and contraband detection system. Say that we have a lot of questions it really is 45 questions that we prepare for this section. I don't believe that we will have time to go all over the question, but as I do every week, I will send those questions probably next Monday if we cannot go to all the questions. Say that, welcome again to Alan, that is helping us to present this, to do the presentation in this study group. And Alan, you can take the control.
Okay, great. Let me share my screen. I've got a little camera problem right now, but I guess it doesn't matter too much. Yeah. You can see my fake backdrop instead. Okay, so let me share my screen and we shall start. Can everyone see my screen?
Yep.
Good. Okay, so this is going to be domain 2, task 2, and this is going to be determining appropriate physical security measures. It's going to include access control. It's going to include intrusion detection systems. And well, yeah, basically that's it. It's an interesting section, one of my favorites, because there's all sorts of technologies that we're going to be talking about that are to me, are very interesting. And I hope you find them as interesting as I do. So without further words, let's start. So we're going to be talking about electronic security systems. So this is what you will find to be essential in modern security designs. They are everywhere, and they're getting into every facet of physical security. It's going to include access control. We're going to be talking about credentials and biometrics. We're going to be talking about video surveillance, live and recorded, intrusion detection, sensors and analytics, and integration with alarms, fire, and building management systems, as well as redundancy and failover features. So let's talk about access control. Access control is basically credential based, right? Your credential will allow you entry to a building or a part of a building. It will also control when you can access. And the three concepts for credentials are something you have, something you know, and something you are. Something you have will be a badge or a physical ID. Something you know would be a password or a PIN code to get into a building. And something you are would be getting into the field of biometrics. That will be your fingerprint, your retina scan, your palm print, that sort of thing, or your hand spacing, that sort of thing. And of course, you can combine these for added protection. You can have 2 or 3-factor authentication using any combination of these two. The types, of course, are pins, cards, and biometrics. And like we said, you can combine these for higher security. Also, maybe have a card and a pin at certain times of the day, after hours or before opening time. You would have a combination of both. The key system components of an access control system. We're talking about credential readers and the communication cabling and protocol that we use. We're going to talk more about this. Another key system component is the distributed processing and central databases, management software, interfaces for external systems, and request to exit devices, sometimes called REX devices. We're going to be talking about these. So let's talk about authentication methods. We mentioned this a little bit. It can be single factor with one method, either a PIN, a card, a smart card, a prox card. It can be dual factor using a combination of both, and could even be three-factor for high security. It could be badge plus PIN plus biometric, just to make sure. Common entry methods, photo ID badges, possibly the most basic, and it involves just showing a badge to a security guard and saying, hey, I am who is on this picture. Not the most secure, but it is a method of access control using the human as the card reader to look at your badge. Pins on keypads, your own private pin, or it could be issued by the company. Biometric scans, fingerprints, and coded credentials. That will be magstripe, proximity, etc. Magstripe seems to be going away from my mind. I don't see too many magstripe access control entry systems unless they're really, really old. They're easy to duplicate, and they can be erased also by even keeping them in your pocket with your phone. You still get them in hotels though. My hotel room is access control too, right? But they're still quite prevalent in hotel room applications, but even those prox cards are taking over. Some ways to defeat access control. This is important and quite interesting. There is deceit, which includes social engineering and impersonation. Social engineering is interesting in that it can be a very interesting way to get information from an unsuspecting person. It could mean simply asking questions that may seem innocent, but can get some idea of a credential, of a password or a PIN. And it could be done face to face, it could be done on the phone, or by other communication methods, email, texting, that sort of thing. Impersonation, of course, just means you have the person's badge or credential and you're basically just using it to enter. Physical attack, of course, that's forceful entry or using tools to get in through the door. And a technical attack, that will be cloning credentials and PIN guessing. There's many ways to do PIN guessing. We'll discuss that in the future. Biometric access control. This is the what you are authentication. That would include fingerprints, iris, your hand geometry. All these are unique to each individual person. It's the highest level of identity assurance. It usually is used for very high-end systems or high-end security applications, but there can be a trade-off of slower throughput. So if you have a line of people waiting to get through a turnstile, biometric is probably not the best way to do it. Yes, so that verifies the person, not just the credential. Types of access credentials. We mentioned the photo ID. It is easy to forge with a color printer and the layout of the badge, that sort of thing. Exchange badges, basically information exchange, smart cards. Stored image, real-time visual comparison, and coded prox cards, magstripe, and of course, smart cards. Everything seems to be going towards a smart card these days, coded prox card, and that seems to be the way to go these days. The best practices for credentials. To do the actual badge, it's good practice to, there usually are combined, of course, a photo badge can be a prox card or a magstripe card. But when you are doing a picture on there, make it difficult to duplicate. Use overlays, holograms, dye sublimation is a printing method that diffuses or sublimates ink onto a plastic and makes it very hard to remove. And watermarks too. Use that sort of thing to make copying of the badge very difficult. The credential stock and the printing area that you're doing the badge issuance from has to be very secure, obviously. You don't want people walking in and getting access to blank cards or to the printer, so they can probably just, when no one's looking, make their own badges. That area must be very secure. Another best practice is to assign zones and time restrictions. make sure that someone who is perhaps working in the shipping and receiving dock shouldn't have access to research labs. Make sure the card, when they swipe it, will deny them access. And then, of course, the best practice also is anti-passback. It basically ensures that once a person enters a secure area, they can't reuse their access card until they first exit. So anti-passback, or should I say passback, would be, of course, swiping your card and then passing it back to someone behind you for them to use it as well. So anti-passback features are quite prevalent in most access control systems. And the visitor logs, make sure you have good visitor logs and make sure that they're well maintained. And if you issue visitor badges, then everything should be entered into the system and a visitor badge issued and logged. Credential management includes enrollment and deletion. And of course, in credential management is usually the software that is used in your access control system, whatever manufacturer it is. So that would include enrollment and deletion. So enroll new users and delete people who have left the company. Very important to keep up with that, obviously. Typically uses a centralized database. There are some distributed databases out there, but centralized, I think, is more common. Definitely use time date-based permissions, so allow entry only after 8 a.m. and before 5 p.m., something like that. And you should support, obviously, audits and alerts. So if something happens with a badge where someone tries to get into one of the secure areas, that should be logged as well, so that you know who the user is, where he tried to enter into. And any credential management system must meet data protection laws. Pins in access control. We've all used pins. We use them at the ATM. We use them as a secondary two-factor authentication sometimes. They're assigned or user selected. The risks there obviously are observation. So someone's looking over your shoulder as you are typing in your PIN. Coercion, someone can actually force you to give your PIN. And writing down. Do not put your PIN on a Post-it note and stick it on your desk or stick it inside your wallet. That's not good practice. Another risk, of course, is looking at a reader, a credential reader that may have certain numbers used more commonly than others. That could be a sign that those numbers are a combination of those keys that are worn or dirty or covered in, fingerprint dirt, something like that. The mitigation for these risks would be scrambler pads, which basically gets you over that vulnerability where the numbers can be that are used more commonly are worn out or dirty. The scrambler pad, you enter the code and automatically, well, each time you try to enter a code, the number layout will be totally different. Instead of 1, 2, 3, 4, 5, 6, it might change it, but you still put the same PIN code in, but the scrambler will every time will mix up the order of the numbers. Duress PIN, that is something that if you are under duress and someone is trying to coerce you out of your PIN, you can put in the duress PIN, which may be a code known to the system. That PIN, that duress PIN will then alert someone in the security operations center that, hey, this guy is having trouble. We better check this out. So duress PIN is an important part of a PIN in access control. Credential encoding technology. So this is where we get a little more technical. Magstripe, common but very clonable. You can copy a Magstripe card. There's machines out there to do that quite easily. Prox cards, they can be passive or active RF. They can either just be dumb wires or antenna, or they can actually have a chip in there. Smart cards for encrypted data exchange. And the type of communication protocol, usually between the reader and the central database or the central management system, would be either weekend or OSDP. Weekend is older, still used. Weekend is a one-way protocol. OSDP which stands for Open Supervised Device Protocol, OSDP, yes. Open Supervised Device Protocol is a two-way communication protocol, much more secure, and is probably used much more than WGAN. WGAN is very legacy, and a lot of people are upgrading to a more secure protocol. Access control design planning. What to look out for when you're planning a system is the throughput at the entry point. Typically, this usually concerns turnstiles more than anything. You know, the turnstiles, when you're a large office building, people are coming to work in the morning and they swipe a card, the turnstile lets them through. That throughput is very important and should be part of your operational requirement. Integration with alarms, video, and human resources, very important also. Alarms, obviously, if someone misswipes or it's card that shouldn't be in the database, then that should be alerted to your security operations center. Integration with video is always a good thing too. Maybe have a pan tilt camera zoom to a preset based on a misswiped card or a wrong card or an out of sequence card. Compliance and life safety codes also extremely important. We'll talk about that in a couple of slides down the road, but those things like ADA and other life safety codes, National Fire, NFPA, that sort of thing, they should be adhered to religiously. And remote management and multi-site control. We're just saying here that if someone, the admin of the remote management or admins, if they're not on site, if they're traveling, or if they're in a different building, they should be able to log in remotely with an app or something else to do management as needed. Objectives of access control systems. The idea and the objective, it's not just about locking doors. There's a lot of data going around and a lot of things that have to work in sequence to make a well-run access control system. That includes the authorization of personnel and vehicles. It includes audit for access events and exceptions being people who are not supposed to be in a part of the building or the card is not read. That will be an exception. That should be logged. And detecting contraband or asset theft. We're going to talk about contraband in the next section. Actually, the last section we'll talk about contraband and contraband detection. And of course, the objective number 4 is to enable alarm event for unauthorized access. So if someone swipes a card, they just left the company the previous day, obviously that should have been taken care of in your your employee management system. And he should not be in the system, and that should alert the SOC that something is not right. Integration with other security systems. I mentioned maybe a pan tilt being part of it, where it swings to a preset when someone misswipes a card or the card is not read. That will be integration with your video management system. Integration with visitor management and HR databases, also important. You want maybe to key or to create a visitor card for vendors or for temporary people who are there for a presentation for a day or something. You want to make sure they have cards that are integrated into your access control system so they can maybe access certain parts or be denied access to everything except maybe restrooms or the area they're visiting, the conference room they're going to be in. Integration with the intrusion detection systems, very important. We'll talk about this down the road. Alert your intrusion detection system if the card is not authorized. So if it's not swiped correctly, then that will be like a potential intrusion. And emergency notification systems that should also integrate with that, and for evacuation orders, that sort of thing. Talk about remote access, as we mentioned before, multi-site control. There's typically centralized control software, as we mentioned. The software allows admins to manage doors, credentials, audit logs remotely, read the logs remotely. Very important. If something does happen and the admin is traveling, they can actually log in and see what's going on, what happened. It could, whether it's cloud-based or centralized, it doesn't matter. You should still be able to have that ability to do remote management. Also, it helps if you have dispersed facilities, several offices maybe in the same town or the same state or the same country for that matter, or worldwide. It's good to be able to see what's happening in various locations. Yeah, so for instance, in the company I work for, we had several offices in larger cities, and our access card will allow us entry to every one, no matter where we were, which was a nice plus. We didn't have to wait and get a visitor badge. We could just swipe right in. Access control and life safety, very important. Two concepts for fail safe versus fail secure. This is what you can set up in your management system. Fail safe is when something happens, your power goes out, your whole system goes down, your access control system goes down. Fail safe would make sure that the doors are unlocked and ready for egress in the event of that failure. Fail secure is the opposite. If something happens with a power outage or whatever, the doors will all lock. There could also be a combination of the two, where certain parts of the system will shut down doors or lock them, I should say, and others will be open for egress. Some examples, a correctional facility, let's face it, should be fail secure, right? If the power goes out in a prison, you don't want all the doors to unlock. So that's a good example of fail secure. Fail safe would be a standard office building for evacuation. That's when, if something happens, if the system fails or the power goes out, the door should all unlock for evacuation. Life safety, we must comply with NFPA 101 and local codes. NFPA 101 is a life safety code. And this also includes ADA as well, Americans with Disability Act, to make sure anyone can egress the building safely. And the big point of all this is that emergency egress must not be impeded by your access control system or overridden. Let's talk a little bit about insider risks, still a major threat. So role-based access control is basically what I mentioned before, where you are allowed entry to various zones as needed. Someone in HR should not be allowed access to the development lab. There's really no reason for them to be there. So their card credential in your software, in your credential management system, should allow them access to where they need to go, but not allow them access to restricted areas. Audit trails and log reviews. Did that employee try to enter a secure area? And why? Track them down. You can tell, but his name is encoded into the card, so you'll know who it is. And you can then take the action further if you need to and find out what they were trying to do. Two-person rule for high-risk zones. So either 2 valid card holders are needed, or it could be biometric. It could be 2 fingerprints are needed, or 2 palm profile, or 2 retina scans. That's for extremely high-risk zones. Think military and DoD. And regular credential audits are extremely important. That should make sure that employees who left the company are not in the system and do not have access to any doors. Or maybe the roles changed within the company. Maybe they moved to a different department. Maybe their role-based access control needs to be adjusted, that sort of thing. Let's look at some common threats that you might have with access control. Very common one is tailgating. That's when you swipe your card, you go through, and there's someone right behind you using your card swipe for entry. And people are nice, really, aren't they? If someone is behind you and they're maybe running towards the door, you might hold the door open for them, not realizing that he's going to get through on your swipe. So part of this, of course, is policy and procedure and educating users. Do not let anyone through on your card swipe. Make sure they swipe the card, make sure you see the card and they swipe it too, then they can get in. So tailgating's very, very common. There's technologies around that can mitigate that. There are some video systems. There are some systems that can detect two people in a zone that shouldn't be there and then key in or tie in with the access control system. Two people, one swipe as an alert, and they'll let you know that. Badge cloning. More common probably in mag stripes. RFID duplication is not as easy, although the tools are readily available to do that. Social engineering, we spoke about that. Again, that can be just a nefarious way of getting information from people. It could be as simple as maybe going to a reception desk and asking, tell them you're lost, and maybe see a picture on the receptionist's wall and say, oh, that's a pretty dog or whatever. What's the dog's name? They might tell you the name. They might tell you all sorts of things if you're nice enough to them. And it may not seem like much, but that kind of information can be extracted and used to maybe guess passwords or PIN codes, something like that. And shoulder surfing and coercion. We mentioned this before. Shoulder surfing, that's another name for looking over someone's shoulder. Common also in ATM applications. What's your PIN? You know, they want to know. And then reading it and then getting in. That's why the PIN is probably the least secure of any access control method. Countermeasures for attack types. Any kind of deceit, and that includes my mind went blank. When two people go in with the same swipe, yes, my brain is totally gone. That is employee awareness and training, definitely there. Physical, if someone tries to break down a door, obviously, if it's a very secure area, there should be hardened doors with layers of delay. Remember the 4Ds and the defense in depth. So that should be hardened. Make sure those doors are safe and cannot be broken down without a lot of effort and time, which causes your delay. And technical, that would be encrypted credentials and protocols. That's a countermeasure, of course, for using perhaps OSDP and anti-passback and other methods. So, access control system best practices summary. Use layered authentication, 2-factor or 3-factor as needed, depending on your security level. Secure credential issuance and revocation. So make sure that area where badges are printed, where the database is held, the computer system where the database is held, and your access control system, make sure that is extremely secure. Monitor and audit regularly. Make sure your logs are up to date and make sense. And design with compliance in mind, because if you design and then you find out there are compliance issues when you're all done, that can be a major, major headache. So anytime you design a system, keep those compliances, ADA, NFPA, whatever, in your mind as you're designing a system. And integrate. Integration is extremely important. Make sure the manufacturer you choose has got a good integration background. They're not all, they're not all just all about themselves and their own systems. And make sure they integrate with a broader security ecosystem. Proprietary, that's the word I was looking for. Make sure they're not proprietary. Okay, so that's it for the access control. Are there any questions before we move on to contraband detection? If not, I will move on. Contraband detection. I love this part. There's all sorts of interesting things going on in contraband detection. And there's a lot of science, a lot of technology, and it's a very interesting area. So contraband detection systems. used to prevent entry of unauthorized materials. That can be at a border crossing. That can be at an airport. It can be anywhere where you don't want anyone to have unauthorized materials. Detection, it should be able to detect metals, explosives, and chemical biological agents. And it's essential in secure areas and high-risk facilities, whether you're an airport or the DoD or anything else. It's very essential. And I hate to admit this, but there's a really good show on TV called Contraband Caught at the Border. And it shows what lengths people will go to get contraband through border crossings or through their luggage at the airport. They will, in border crossings, they will actually drill out the cars to make space for narcotics. They will put narcotics into the tires of cars being brought in. It's absolutely amazing what they do. And it's an interesting show, kind of a reality base, but it's a very interesting show, a lot of learning there too. Metal detectors, you've seen those at the airport. Unfortunately, they're used in schools too, at this point, universities, but they detect ferromagnetic materials using magnetic fields. So if there's a disturbance in that magnetic field from the metal in your pocket, it will trigger the alarm. There's walkthrough, as you've seen at the airport, and handheld types, the wand, the scanner. And this, what it does is it mitigates threats mostly from metallic contraband and, of course, firearms. They're also used in courthouses and used extensively and in education these days too. The challenges of metal detectors are any false alarms from static metals nearby. Electromagnetic and lighting interference can cause a problem, and any embedded rebar in concrete that is around about. And sometimes these don't show up immediately. You can be putting in a metal detector loop when the building is under construction and you don't have all the things in place that will be there. When the building is complete, then you find these challenges. Luckily, the metal detectors themselves can be calibrated. So it's just a case usually of doing a recalibration to make sure everything is working correctly. So the challenges would be in that respect mitigated. Okay, package detection, X-ray systems. X-rays, it's very similar to what you get in the hospital. It can see basically through using X-rays, and they screen package for contraband. There's two types. There's single energy that show density differences, and multi-energy, which can identify material composition. Single energy uses a single energy spectrum. Multi-energy uses two different energy spectrums, high and low usually, to get you more detail. So that would identify the actual material composition. Oh, one more thing. The single energy systems struggle a bit. They're not as good. They may not be able to tell the difference between flour and a powdered narcotic. So it's just normally people at this point in time would use multi-energy. But just so you know, there is a difference between the two, maybe a legacy system or something like that. On to CT systems, computed tomography. This also is used in hospitals, and it would be the same kind of idea. It would do basically a 3D color scan of your body and can be used for aiding in diagnosis. It's part of a radiology tool in hospitals. So they create 3D images of packaged contents. You may have seen them in airports these days. A lot of the airports, I should say, are upgrading to these systems. If you sneak a look over what they're looking at, you'll see a very highly detailed color view of what they see, and the color denotes what kind of threat level it might be. So very, very modern, but very, very comprehensive. CT will analyze mass, density, and composition, and used for cargo screening too, and mass detection of cargo. So very useful. So on to explosives detection. This is where it gets a lot of science involved in this, a lot of nuclear-based techniques. The techniques that I'll be mentioning are all usually in a portable box of some kind, so you never actually interact directly with any of these elements or any nuclear energy. It's all built into quite a small box that can detect various types of things, including explosives. So they use radiation and electromagnetic responses. So you penetrate what you're looking at with radiation, and you're looking for a particular electromagnetic response, neutrons, gamma rays, that sort of thing. So any gamma rays produced, they're characteristic of the composition of what you're looking at. And of course, that is calibrated to what kind of things you don't want to see, what kind of explosives. So it really shows you the absence of or presence of explosives. So these are some of the offshoots from using the radiation, and it includes TNA is thermal neutron activation. PFNA is pulsed fast neutron analysis. I wouldn't worry so much about remembering these. I don't know, Nelson, I don't think this is in the test, but
no,
it's good to know its background.
You are right. It's a lot of information in the material about explosive, about detection system, but it's not the technology. It's a lot of material, but really in the test, my experience is not too much. Okay, you don't need to remember all the technology that is on the material. I think that you need to have in mind is the general view, the general acknowledgement about those systems.
Yep. And so it basically just is various types of nuclear systems. Raman spectroscopy he was the inventor of this system, and it's just a way to look for a signature, basically, on a readback. Next up, we've got trace methods. I'm sure you've all seen this at the airport too, where you may be randomly, or it may be further screening, where in the US, the TSA agent will wipe your laptop or your phone or something with a piece of material, and that swipe will give them particles on surfaces that they can use to further investigate. There's the other. So it can be, it's accurate, but there was a case where a passenger, an airline passenger, was at a shooting range that morning, and he still had residue on his luggage from that, on his carry-on bag. So it can detect that. It's very sensitive. So IMS, that again, I wouldn't worry about remembering, but it's ion mobile spectrometry and chemiluminescence. It's basically the light coming out of a detected sample. So on that, here are some trace detection technologies. We've got IMS that we mentioned before. This is one of the nuclear systems. Mass spectrometry and chemiluminescence used with the swipe. Fluorescent polymers. It's really for biohazards. So if you remember, many years ago, there was an anthrax problem with people mailing anthrax to various politicians. So that is what fluorescent polymer system can detect. It's also used for, well, it's biohazard and environmental monitoring. And don't forget canine units. Dogs have extremely sensitive noses, and they can be your first line to detect something that they're trained to detect. From there on, you can take the user aside and then do further testing based on any of the previously mentioned. But dogs, you cannot overlook dogs and their usefulness in these fields. Okay. So for things like anthrax and anything in the air or a powder, it uses point sensors, just various sensors based on um, the technologies we mentioned before. And you must balance detection with low false alarms. We're going to be talking a lot about false alarms in the next section and nuisance alarms. We'll discuss that. And any biological detection is slower and complex because of all the stuff you're doing to it. So typically you have a reagent that you would use in terms of a swipe, and you would have that reagent react with what you swiped to give you the desired readout. And that's pretty true of the other systems that we mentioned too. The other non-scanning systems, not the CT or X-ray systems. So if no questions on contraband detection, I'll move on to intrusion detection systems.
Hey, Alan, before moving into the intrusion detection system, we have a question about access control in the
Okay.
chat. That is, there seem to be always problem with electrified door hardware. What kind to use, who provides, who wires, how to ensure compatibility. Any thoughts, advice about that? Yes, it's a common problem with door hardware. And I would like to be this more interactive. And I don't know if we have a certified locksmith here, and he's a project manager for Pref Tech. Is Dylan. Do you want to jump in this question and say something about your experience with door hardware? What is the thing that happened in the field? Why? Because we have those problems every day.
Mm-hmm.
Tell us a
Yeah.
little bit about your experience.
Yes, absolutely. I mean, selecting door hardware, it really depends a lot on what you're dealing with in terms of pre-existing conditions vis-a-vis the door frame, all that sort of stuff. I mean, is this environmentally specific that we're asking the question about, or?
No, in general, the question is a general question about problems with electrified door hardware. What kind of to use the kind of door hardware? It will depend on the kind of door. Who provides the door hardware? I think that the question is going more in the electrified door hardware. My experience is that many problem with the door hardware is because it's not a good definition of who is in charge of the door hardware and who is in charge of the electrified door hardware. Many times the door hardware company, Division A, they install the door hardware, but they don't have the experience. Can you tell us a little bit about your experience with that?
Yes, no, absolutely. So when it comes down to door hardware, I have a strong preference towards electrified door hardware that involves free egress and not the use of like maglocks. And that really has a lot more to do with the ability for it to be fail secure rather than fail safe. It also provides a lot more opportunities for um, sort of an enhancement to an already pre-existing design. It may be more difficult to install, but it's also much less apparent to any sort of potential, threat that the door is actually electrified. The use of free egress hardware allows for just less on the permitting end, but again, there are a lot of different choices that can be had when it comes to door hardware. Again, a lot of them come down to environmental constraints and budgetary constraints. I mean, it's sort of a loaded question when just open-endedly asked, but whoever has questions about it, if you reach out to me on individually, I'm more than happy to answer anything you've got, and kind of walk you through sort of how I would select things. But again, without sort of a case-specific example or knowing what your constraints are, it really is difficult to individually answer sort of how I would approach it. In general, free egress.
Yeah, I will
But
say, David, in general, if you are designing the system or you have a RFI or RFP, and you can um, design the system in order that Division 28, the integrator, install the door hardware, the integrator, the install the cable that is part of your question, who wires the door hardware. If you can do that, you will avoid many problems. Most of the problem in my experience is that the electrified door hardware is installed by mechanical locksmith companies that they don't know really well how to install those systems, or in many cases, the consultant in set up a door hardware that is not the correct door hardware for that particular door. If you have the opportunity to talk with a consultant and basically the integrator that is doing the job, the project, install that door hardware, you will avoid a lot of problems. Okay. Any other question? No.
Okay, great. Thank you. Thank you, Dylan. Okay, so no
always happy to
questions.
help.
Yep, thank you. Okay, so one of my favorite aspects of this section, intrusion detection systems, they can be very interesting in terms of the technology and various methods to deploy. So let's look at intrusion detection systems. Let's start off with performance characteristics, what we're looking for in terms of performance. The first one is typically called PD and probability of detection. That is basically how efficient will the sensor be in detecting. The highest possible number is 1.0, but no sensor is 100% efficient, no matter what any manufacturer may tell you. You might see numbers in the 80s and 90 percentile, but again, that is the PD. That's the probability of detection. The other criteria or performance characteristic is the nuisance alarm rate. That is basically any alarm not caused by an intrusion. So it could be an animal, a deer, for instance. A deer head on is actually much the same size as a human. So a detector that detects that, it might just need calibration, or it may just be something you have to live with, or just not let deer into the area. But nuisance alarm rate is very important because that can make people or the operator tune out of the system as it's supposed to be working. I remember, I think it was JFK Airport several years ago, there was a guy who had too much to drink on his jet ski. He managed to get ashore in Long Island and climbed over the fence at JFK Airport. The alarms are going off, but there were so many nuisance alarms from geese, from wind, from God knows what else. The guy actually got over the fence and no one confronted him. So he's walking around a JFK runway on the tarmac, basically, after having gone over there. So it's important to note that nuisance alarm rate has to be as low as you can get it. Now, not to be confused with false alarms, and there probably will be a question on this in the exam. There always seems to be one. You have to know the difference between a nuisance alarm and a false alarm. A nuisance alarm is, as I stated, it's caused by environmental things. False alarms are usually caused by the equipment itself, either poorly calibrated sensor or poor design or poor integration or poor placement or poor maintenance. It could be some kind of optical sensor that's looking to see thermal or light, and the sensor is dirty. It's covered in a layer of dust and it can't work efficiently. So if that goes off, that's a false alarm. So it's important to note nuisance alarm is usually caused by environmental problems, wind, rain, snow, animals. False alarms are caused by equipment miscalibration or failure. And the other criteria, there's only three. There's probability of detection, nuisance alarm rate, and vulnerability to defeat. So vulnerability to defeat is, as the name suggests, how easy is that sensor to bypass? How easy is it to disable? Is it at a point where you can pull a plug on it? Can you cut a wire? That is vulnerability to defeat. So a little bit about intrusion or physical intrusion detection systems. I've seen them called PIDs, PIDS, or IDS, IDS. But physical intrusion detection systems, what are they? The core function is to detect intrusion attempts or pre-alarm events, something that happens. Maybe you have a sensor set up before your perimeter, so you can get pre-alarms on that. The key components are sensors, video alarm assessment, that will be video verification, access control, alarm communication systems. That are key. Those are the key components. The purpose is to identify unauthorized entry attempts. That's the whole purpose of an IDS. And they could be interior or exterior systems. There might be questions on those in the exam too. I'll elaborate later. And the overall goal is to reduce nuisance alarms and integrate into a physical security system. Or actually, PPS is physical protection strategy. I apologize. Key performance characteristics. We'll go back over probability of detection, PD. This is the likelihood intrusion will be detected. It's always less than 1 in real life. No sensor is 100% efficient. The nuisance alarm rate, number of false alarms over time. How many would that be? You can work out that average. And again, this is caused by natural occurring phenomena. And the goal is 0 in an ideal system. So the ideal is 1 for PD and 0 in NAR, but you'll never get either of those. And vulnerability to defeat. Ease of system circumvention. The methods of defeat can be bypass, adversary path exploitation, which basically means, take for example, a simple PIR detector. They're very good at detecting anything that crosses the path, left to right or right to left. But as you walk towards them, they're not quite as efficient. So that is an adversary knowing what type of sensor it is and exploiting the weaknesses that way. And spoofing, that is basically a way of making it seem that there's no threat there, that the sensor cannot detect a threat, however you do it. The only thing I can think of there is Arnold Schwarzenegger in Predator, when he covered himself in mud to hide himself from the predator and his infrared vision. Alarm initiation conditions. Beyond just simply detecting an intruder, there's also other factors to initiate an alarm. A change in safety or process condition. That could mean an increase or sudden decrease in temperature or the presence of smoke. So that could be a threat just beyond just unauthorized entry. Loss of electrical power. That would be alarm initiation. You'd want to know if your power is lost. You may want to think to yourself, how can I show power is lost? How can I get an alert if power is lost if there's no power? Well, hopefully you have backup, at least in your SOC. And if it's just a simple case of having a sensor that can detect power loss, it will be a relay, perhaps, inside the sensor that is normally closed. And then when power is lost, it opens up, giving you indication that power is lost or something is wrong. Tampering, each of these sensors should have an anti-tampering system, as simple as using security torque screws or an indication that tampering has taken place by having some sort of sensor that detects that a door or latch is open on the sensor itself. And then, of course, the sensor failure itself. A good sensor should be able to tell you if it's no longer detecting. We always have to go back to industry standards and grades, and there's a few, not as many as you might think, but for detectors, we've got certain standards. We've got UL. Everyone's seen UL stamps. They're on every piece of equipment out there. For sensors, it is UL 681. Underwriters Labs, UL is a US-based company in Illinois, and they do safety testing for anything and everything. ASTM is the American Society for Testing and Materials. They're based in Pennsylvania, in the USA, and they do they write standards basically. They develop security standards. Some of the titles include building security and design considerations for high security interior intrusion detection systems. That's a mouthful, but that is the kind of documents they come up with. And then in Europe, we have the EN standards and the BS. The BS EN 50131, grades 1 through 4. Grade 1 is for a lower attack level, so it would take into account that your intruder or your threat would be a low grade threat, in that the person doing the intrusion would have limited knowledge and basic tools. 4 would be the highest threat. Advanced tools and high risk. That makes a 50131 grade 4 suitable for very high risk applications. This is in Europe only. So let's talk about exterior intrusion sensors and classifications we have. The operating principle they work under can either be passive or active. Passive do not emit anything. They are pure sensors that take in information. Active usually emit either radio frequency or laser or radio frequency of some kind. So passive is a simple device that takes in information through some sort of lens or sensor itself. Active emits. So we're talking maybe for passive, it would be a PIR, a passive infrared device. Actually, even a camera is passive, right? It doesn't usually emit anything unless it has an infrared sensor on it. But a camera by itself is typically a passive sensor. Active would be radar. It would be LiDAR. It would be anything that emits something. Second classification is visibility. Is it covert or is it visible? A covert in itself gives it, they're designed to be hidden, often buried underground. So they're very difficult to defeat if you can't see them. Visible is usually right there in front of you. It could be a PIR or a camera on a pole. That can be also a deterrent if you want, one of the 4Ds we spoke about. But if it's covert, that is a great way to catch someone if they don't even know they're being detected. That is an incredible way to do that. Detection pattern, line of sight, that will be typically like, think of your garage door sensor that goes along the bottom of the garage door to make sure there's no kids or anything in the way of the garage door coming down. That would disable that path, that beam if you want, and it would stop the door from coming down. There's also beam detectors that rely on a transmitter and receiver unit to across a gateway that would detect that when that beam is broken. Terrain following is, as the name suggests, is basically they're designed to adapt to uneven terrain and any elevation changes. Detection volume. So there's 2 types of sensors in that they're volumetric or line detectors. Think of volumetric, another name for it might be an area sensor. It detects an area. A line detection detects a line across, perhaps a fence line, or in some sort of application where you want to detect direction. A line detector would tell you what direction someone's traveling, whether it's broken the line left to right or right to left. So volumetric versus line detection. It's good to be familiar with this term volumetric, but think of an area sensor. And then the application is the other classification, buried line, fence systems, or freestanding systems. So these classifications is a way to kind of select the most suitable sensor technology for a specific application and environment. So common exterior sensor technologies, you've got fence disturbance sensors. They can be fiber or they can be any other way, but They're typically mounted on fences, and they detect vibrations, movement, or tampering. This can be a problem. They can be very sensitive. If they're not set up correctly, they can be a pain because they continually get nuisance alarms and false alarms because sometimes they're just not set up correctly. And in that same mode, taut wire and fiber fences. So taut wire is basically a very tightly strung wire that's across the fiber fence. If it's disturbed, if it vibrates, it will trigger. And fiber uses fiber optic cabling to detect any output, light output level at the receiving end is disturbed. It's very sensitive and can be a headache to set up. There's also electric field or capacitance sensors. They create like a field around a perimeter, and they detect changes when an intruder goes through. The capacitance changes, and they can alert based on that. Infrared and microwave sensors. Infrared, of course, detects body heat in most cases. They detect if something with body heat is going across their path, and they can be passive or active too. PIR is passive. It's basically just a receiver. But on some surveillance cameras, you have an active sensor that emits infrared light. That would be called an active sensor. And then there's microwave sensors too. They transmit and receive microwave energy. You can do sometimes speed estimation and direction. So they're quite useful. Ground-based radar, sometimes called GBR, and LiDAR. LiDAR is a laser-based radar. It uses a pulsating laser beam to basically give you similar results to ground-based radar. Both of these can be used to estimate speed, direction, and distance. And exterior video motion detectors. That can be basically tied in with your surveillance cameras, where you get anything from basic video motion detection. If something moves in the field of view, it alerts, or more advanced analytics. It could be loitering detection, it could be line crossing, or any combination. So that is a brief discussion on exterior sensors. Let's look at interior sensors. And yes, there is a difference that we will discuss in a couple of slides from now. So the operating principle, visibility or detection volume. Visibility being covert or visible, and detection volume, that's area. Most indoor sensors are volume type, volumetric or area type. Boundary penetration sensors, that can be used, they think of a glass break sensor. So that would be doors, windows, even a sensor on a door or window that detects when the door is open or the window is open. And even walls or ceilings can be protected using boundary penetration sensors. Interior motion sensors, they detect movement within a designated indoor area, such as a room or a hallway, and proximity sensors. So that would be detecting an intruder near a specific object, like a safe or another valuable asset. And then there's specialized applications. There's trap detection for expected travel paths. If someone always goes a certain way, if it goes a different way, it can trap that. Spot protection for focus protection, channel detection for narrow or broad areas, and then volumetric, as we discussed, for comprehensive area coverage of a room. Common interior sensor technologies, a little different than exterior. Vibration, glass break, magnetic contacts. We've all seen glass break detectors, magnetic contacts on doors and windows. Interior motion sensors, microwave, PIR, passive infrared, and dual technology, which is a combination of both. This brings in mind one question that always seems to come up in the exam is a type of sensor used for indoor use to monitor a room if an adjoining room has heavy traffic. One bad effect or one bad technology, not technology, but side effect, if you want, of a microwave sensor in a room is that it will pass through the wall and detect movement in an opposite or adjoining room. So that question always comes up, it seems. what sensor would you not use to monitor a room if there's a busy, high traffic room next door? And the answer would invariably be microwave. That is one drawback of microwave. That's why you might be able to use dual technology or just PIR for an area, which is kind of very difficult to defeat in a single room environment. It can't get any bad effect from an adjoining room. Video motion detection, VMD for short, of course, we've dealt with that. Proximity sensors, capacitance sensors for area or for asset protection of a particular device. And then wireless sensors too. They could be Bluetooth or Z-Wave or one of those other technologies. They do require batteries and they can be susceptible to RFI, radio frequency interference. System integration and optimization. Protection depth, layer detection. We've been talking about this since we started doing this, but you can use all these sensors for protection and depth in layers. I find this interesting. Sensor combinations, or versus and logic. So when I was a lad, we learned about or gates and gates, but you can use that theory basically for sensors too. So an OR gate gives an output if any one of its inputs is active. So if you have the input from an alarm system, several inputs, 3, 4, 5 different types of technologies going into an OR gate, if one of them gets triggered, there will be an output from the OR gate that will give you an alert. But think of an AND gate, where an AND gate requires every input, no matter how many there are, if it's 2 or 4 or 6, every input must be an active high or a 1 as opposed to a 0. Then the AND gate will give an output. So imagine if you had PIR, if you had a thermal camera, if you had microwave, all giving its output into an AND logic system, that will be pretty good for your probability of detection and your nuisance alarms, right? Clear zone establishment. There may be a question on this too, just so you know, on the OR versus AND. Clear zone establishment, this goes way back to, like I said last week, medieval times, where you always wanted to have a clear zone around your perimeter and any roads coming on to your perimeter. This goes back to castles. They would always have a clear zone around them so they could see who's coming to attack them, right? So they're not working in the woods. And integration with video and barriers. So you do want your integration, your PIDs or your IDs to integrate with your video and your barriers. So typically with video, it will be a video verification. So a sensor is triggered, it comes up in your security operations center. You want video verification of something actually happened. You don't want to send a guy out there just to see, that takes time. You want instant video verification. Swing your pan tilt camera, see what's going on at that location where the sensor was triggered, and then make sure that it looks safe. Integration would mean automatically swinging a pan tilt, a zoom camera, a PTZ camera to that location based on its direction and where the vulnerability was broken through. And barriers too. You can also have barriers dropped based on intrusion detection. That's a delay tactic. Factors affecting performance will be physical, environmental, of course, terrain, weather, wildlife. Snow, rain can affect certain sensors more than others. Tamper protection and supervised lines. There should be at least security torque screws in there that people have to hunt for a good screwdriver to get it out. And supervised lines. There should be a supervised line that knows when it's being cut, either as simple as data communication or resistors at the end that give a known resistance to what it should be. Every good sensor should have a self-testing capability. It be part of a maintenance procedure, a monthly procedure maybe, or a 6-monthly procedure. Self-test that alarm. Is it still working? Or that sensor, I should say. AI is coming into everywhere, as we know, but there's now AI-based pattern recognition sensors that makes it very good for your nuisance alarms. It can detect trees moving versus perhaps an animal versus a person, or versus a fence break or some other violation. So AI is sneaking its way into even in sensor world too. And then installation and maintenance. The sensor has to be installed correctly. It has to be maintained correctly. After installation, of course, it has to be set up correctly. It has to be calibrated correctly. And it has to be made sure that the sensor window, whatever it is, if it's a lens, if it's some other method, it should be clean and free from dirt. So all that needs to be done. So conclusion. Intrusion detection systems are fundamental to security. It's part of your plan. It's your 4Ds or it's your defense in depth. You've got to do that performance balance, your probability of detection versus your nuisance alarm rate. You must adhere to security standards. As I said, if you do leave that till later in the day, you might get burned. And use diverse sensor technologies. Have a backup. Use microwave and PIR. Use a thermal camera. Use various types, and give you that defense in depth that you're looking for. And strategic integration. Integrate well with your barriers, with your video management system, and even your access control. And be aware of your environment. What changes in the seasons when the seasons change? Do the leaves grow more? Do the leaves all go away? Is there snow on the ground? That sort of thing. Be aware of your environment. Okay, we ran a little bit over, but that is this presentation. I know it was long and I apologize for that, but there's a lot to know and a lot to learn. And if there's any questions, we can maybe take some until and then we can go on to the questions or the practice test. Okay. So we've got, what, 15 minutes maybe to go through some questions. I'll do as many as I can. So this is going to be on all three subparts that we learned about tonight: access control, intrusion detection, and contraband detection systems. They're mixed up, so they're not in any particular order, which is good. So the first one is the three main characteristics of intrusion sensor performance that system designers must understand to design and operate intrusion. We just did this, so it should be fresh in your head. And this is a good typical question. Okay.
Barcode on this.
So, I'm sorry?
We're not doing a QR code. Just put the response in the chat.
Yeah. In the interest of time, we figured it might be quicker just to go through the question, and then the next slide will reveal the answer. But you can put it in the chat, definitely. Yeah. Okay, so the answer is PD and NAR. We learned that. We should know that. None of the others are anything to do with anything. And but it's typical of a question, one of the easier ones perhaps, because you should know this and everything else. There's software complexity, SD system durability. That this is, I would call this a fairly easy one. PD for a specific sensor and scenario depends on several factors. Which of the following is not listed as a factor that PD primarily depends upon? Notice the not, N-O-T. Okay, this one should be okay. Obviously, the manufacturer's country of origin has nothing to do with PD. An adversary attempting to defeat an access control point by forging a credential or guessing a PIN is categorized explicitly as what type of attack? I would categorize this as a hard question. It's a little harder. But we did mention this. And the answer is a technical attack, not social engineering, not a physical attack, and it's not deceit, but it's a fine line. This is a difficult question. You really have to know what a technical attack is. And it's right there in the POA. The context of intrusion detection systems, in the context, a nuisance alarm is fundamentally distinct from a false alarm. What is the primary cause of a nuisance alarm as defined in the source? So this question is a popular one in the exam. And we should know the answer, of course, is C. So A would probably be a false alarm, not that. And correct answer is C. That is a nuisance alarm. According to the sources, I think the sources being the POA, what is a primary concern regarding the security of personal identification numbers in access control systems, especially if they are the sole criterion for entry? What's the primary concern? That one should be fairly easy. We mentioned shoulder surfing, right? Exterior intrusion sensors are classified in several ways to describe their operation and application. Which of the following is not a classification category for exterior intrusion sensors?
Sorry, Tim, I asked these numbers are not in sequence. We jump
This
from
one
0 to
is
9. Is that accurate?
fairly easy. Analog or digital did not appear as a classification. When comparing passive and active intrusion sensors, which type is stated to have the advantage of creating fewer nuisance alarms because of their stronger signals? This is a tough one too. You really have to know. So fewer nuisance alarms would be active sensors. It's true, passive sensors do not emit energy, but that really is not what the question is asking. What is highlighted as a significant advantage of smart cards and security systems, particularly concerning their integrity? And the answer is B, the large memory and high degree of resistance to forgery or compromise. Fundamental principle of master keying, I'm not sure if we covered this, but we'll ask it anyway, is to allow what? It's similar to an access control management technique. It's a hierarchy of access to groups of locks, from access to only one lock up to all locks in the population. Freestanding IR sensors are known to be susceptible to nuisance alarms. Which specific atmospheric conditions are cited as causes for these alarms and by blocking the IR beams? And this is a tough one too. There's a lot of good answers there, but if you're blocking the IR beam, then it's going to be something like fog, snow, and dust storms. That is going to deflect the beam if you want, or make it go somewhere else, or bend, or not be as visible to the other sensor. Fail-safe locking mechanism is crucially designed to behave in what way during a power failure or system malfunction? You should know this. So obviously it's to unlock to allow free egress, especially for fire emergencies. When designing a locking system, which criteria requires systematic study to understand the density and movement patterns of people within a facility? That is size and turnover of population. Population being how many people are working. VMDs have certain limitations in their effectiveness. What is a specific limitation mentioned regarding VMD performance and regarding alarm determination? Remember, all these questions are based on the POA and what the POA says, not what your mind might tell you or what your experience might even tell you. It's what ASIS says. So the answer here is if the video resolution is insufficient to allow an operator to determine the source of the alarm quickly, the VMD will not perform well. Oh, I just did that one. Which biometric feature is not listed among the common characteristics used for personnel access control verification in the sources? So which one of these is not listed among common characteristics? Should be fairly easy. Sorry. I didn't highlight, but I think it's thermal signature, right?
No, I didn't include yet, but I think it's thermal signature.
Yeah, we should answer the question too, right, Nelson? It's a test for us. But yeah, thermal signature wouldn't be. There are voice recognition systems that might work, and hand geometry and fingerprint too.
24.
Oh, I think I messed up when I was doing stuff. Sorry.
Okay.
What is a key improvement offered by the Open Supervised Device Protocol, SDP, compared to older protocols like Weekend? We did mention this. And the answer was, of course, it improves. One of the ones mentioned was security. So it supports AES 128 encryption. Times a few more minutes. This is a question on the OR gate. When combining multiple sensors in an intrusion system using an OR gate logic, this has a specific effect on system performance. Which of these performance characteristics is enhanced by using an OR gate combination? So the answer, according to ASIS, is probability of detection. Although I think it may have an effect on nuisance alarm rate as well. But that might be an AND gate would have more effect on that, I think. But an OR gate is basically taking the input from various sources and giving one output no matter which one detects. A comprehensive access control system is also designed to provide information for what specific purpose? Yep. To ensure timely assessment and response to events categorized as exceptions or alarm conditions. Certain physical and environmental conditions can significantly affect exterior detection systems. Which specific condition is noted for its ability to transfer energy into the ground through trees, power and highlight poles and fences, potentially generating nuisance alarms? Think of vibration sensors. And the answer is wind. The primary purpose for which metal detectors are commonly used to screen entrance in physical security contexts, according to the sources, is to mitigate threats involving what? Yep. Obviously, firearms and other weapons. It's metal, right? What is a significant factor that can cause false alarms or interfere with the accurate detection by walk-through metal detectors in buildings? We covered this too. Remember when before the system is being built around, if the metal detector is going in first, anything that's added in terms of metal can affect the detector and it has to be recalibrated. Okay, in X-ray package search systems, what is the primary advantage of a multi-energy X-ray system over a single energy system? I'm not sure if we actually mentioned the Z factor, but that is the answer. So it measures the effect of atomic number and allows a color coding spectrogram. Which X-ray based system or which X-ray contraband detection technology is described as an automated technology that detects small threat masses by imaging contents from different angles using a gantry? That will be CT. Explosive detection, what are the two categories based on the amount of material they analyze? What are these two categories? Bulk and trace, organic and inorganic, liquid and solid, chemical and physical. And for explosives, they're divided into bulk and trace, according to the POA, Chapter 11, Section 11.2. Okay, 2 more minutes. What is the fundamental principle behind neutron technologies for explosive detection? Did mention this nitrogen, oxygen will be an offshoot of the scan. Which trace explosives detection method is highlighted as the most efficient for collecting particle residues from a person's clothing or belongings? And we did mention this also. That is swab sampling. It's simple. And that swab sample, as I mentioned, would be applied with a reagent, and the result would be something that you are looking for. IMS for explosive detection operates by these can be tough. But the answers are all in the POA. So chapter 11, 11.2, page 290, ionizing a gas sample and measuring the time it takes for ions to travel a specific distance in an electric field. What's the primary characteristic that chemiluminescence detectors exploit to identify certain explosives, specifically the nitrate content? Well, it's probably not going to be magnetic. It's not acoustic. It's the emission of a photon when a nitrogen dioxide molecule reacts with ozone. I'll do one more. While expensive to train, canine olfaction is recognized as being particularly effective for explosive detection due to its dogs can be brought anywhere quite quickly. So it's high mobility and the capability. They're very capable of finding that threat. So I think if you don't mind, Nelson, we can stop there. It's 8 o'clock.
Yeah, and it's only, we are missing only 4 questions.
Okay.
Yeah, we can stop here. It's 7 now, Central Time.
Oh yeah, I'm an hour behind, I forgot, or ahead.
Okay, thank you for be here and stay with us 1.5 hours. It has been a great section. Too many people, too many interaction in the questions. And see you next week.
Yep. See you guys. Thank you very much.